Hi, I'm Mr. Kangas, and today we're going to take a look at Chapter 12, Section 8, Counting Outcomes. And in this video, we're going to be taking a look at what is known as the fundamental counting principle. This is basically a way of using basic multiplication to count outcomes, and it allows you to count outcomes that are, hundreds of thousands in number very simply. So this is a great method for counting any outcomes, whether the number of outcomes are small or large. So we'll start with a simple problem. We'll start with the same problem that we used in the previous video, where we had 3 decks for a skateboard. And the deck is like the board, basically the design of the board and the type of board you're looking for, and 2 wheels. Okay, so there's 2 types of wheels that you can buy. And so we just discovered last time via a tree that you had a total of 6 options. Basically, the way the fundamental counting principle works is you're going to take choice number 1. So let's say choice number 1 was decks. So we've got 3 choices for decks. Choice number 2 is wheels, and we have 2 total choices for choice 2. So we have 3 options for choice 1, 2 options for choice 2, and you multiply those together, and you get your 6 total options, total outcomes. So, why does that work? That's really kind of the key question. Why is it when I just multiply all my options together, I get the total number of outcomes? Well, if you take a look at it, we'll kind of go back to tree form a little bit to kind of show it visually. Choice 1, let's say we started with the decks again. Okay, we have decks A, B, and C. For deck A, we have a choice of 2 different types of wheels. Because remember, I had 3 different decks. I had A, B, C, and I had wheels D and E. So we have choice. We have wheel D or wheel E, wheel D or wheel E, wheel D or wheel E. So basically, whatever your first options are, so if you chose to go with decks first, A, B, and C are all going to have the same number of outcomes. Okay, so we have 3 options, 3 starting options, and each of those starting options has a total of, in this case, 2 outcomes. So what we're doing is we're taking the 3 starting options and multiplying that by the total, the 2 possible outcomes for each option. We're multiplying the total number of starting options by the total number of outcomes for each individual starting option. So choice A has 2 options, choice B has 2 options, choice C has 2 options. So in that case, we can do 2 plus 2 plus 2, which is the same thing as doing 3 times 2. 2 plus 2 plus 2 is repeated addition, and repeated addition is multiplication. This is literally saying I'm going to add 3 2 times, or I'm going to add 2 3 times. So I'm either doing 2 plus 2 plus 2 or 3 plus 3. And you can go either way. It depends on what your starting choice is, if you're starting with decks or wheels. If you wanted to start with wheels, it's going to be the other way around. Instead of doing 2 plus 2 plus 2, we're going to do 3 plus 3. So I can show you what it would look like if we started with the wheels. If we started with the wheels, you have choices of wheel D or wheel E. After that, each wheel has 3 options, A, B, and C. A, B, and C. So we can get wheel D with choice A, wheel D with choice B, or wheel D with choice C. We can do wheel E with A, E with B, or E with C. So there's a total, again, of 6 outcomes. And if you take a look at it, each wheel has 3 outcomes each. So each wheel has the same number of outcomes. So basically, if you just did 3 plus 3, 3 for the first outcome, 3 for the first wheel, 3 for the second wheel, because there's 3 outcomes for each wheel. Now you've got your total number of outcomes. So really, if you want to find the total outcome, you don't actually have to do a full tree if you want to understand it. We could have just done one of the wheels. We could have said wheel D, and then we could have said wheel D has 3 options, A, B, and C. So we found out there are 3 outcomes for wheel D, and so I know there are 2 wheels, so I know this one's also going to have 3 outcomes, so 3 times 2 is 6. But really, the fundamental counting principle, if you understand why that works, it works that way for every single scenario you can think of when it comes to counting outcomes. Some scenarios are a little bit trickier than others. I'm going to do 2 more examples, each one getting progressively harder, but none of them are truly all that difficult. If you don't understand anything I've gone over at this point, make sure you pause the video, ask for some help if you're one of my students, and make sure you're taking good notes. Make sure you're pausing the video and taking good notes. Now, what are some other options you may encounter? Well, you may encounter options where, well, there's not just 2 choices. What if there's a third option? What if there are 5 carrying packs as part of this combination deal? And let's call those carrying packs 1, 2, 3, 4, and 5. Okay? So now the number of total outcomes is going to be even bigger because we have more options to choose from. We have 3 different choices now. We can choose a deck, a wheel, and a carrying pack. So again, it's the same as it was before. You're going to start with any of them. You can start with whatever you want. You can start with a carrying pack. Okay? And so there are 5 different carrying packs. 1, 2, 3, 4, and 5. Okay? Now remember, each carrying pack can be matched up with either wheel and any of the decks. So each carrying pack is going to have the same number of outcomes, right? So carrying pack 1 has the same number of outcomes as 2, 3, 4, and 5. So if I just figure out carrying pack 1, then multiply it by 5, I'll have all the total outcomes. So carrying pack 1 can be matched up with wheel D. So we have 1D or 1E. So wheel D or wheel E. Carrying pack 1 with D, carrying pack 1 with E. And from there, you've got 3 options for D, for wheel 1 with D. So you can go wheel D with pack 1 and deck A. So pack 1, wheel D, deck B. Pack 1, wheel D, deck C. Okay, so there's 3 options for decks. And then, of course, over here, it's the same thing. We got 1EA, 1EB, and we have 1EC. So for each carrying pack, if you take a look at the end branches, because those are completed skateboards, pack 1, wheel D, deck A, pack 1, wheel D, deck B, pack 1, wheel D, deck C, and then similar over here for wheel E and pack 1, we have decks A, B, and C. So there's a total of 6 different skateboards for pack 1, which means there are 6 skateboards for pack 2, 6 for 3, 6 for 4, and 6 for 5, which means you have 6 plus 6 plus 6 plus 6 plus 6 for a total of 30 outcomes, or in other words, 6 times 5 for a total of 30 outcomes. So that's kind of the visual explanation of why this works, and now the fundamental counting principle is much simpler than all this. You don't have to do all this. This is to kind of help you understand what's going on. Basically, what's going on is we're just doing, you have 3 choices for decks, times 2 choices for wheels, times 5 choices for packs. Because each deck can be paired up with 1 wheel and 1 pack. So deck 1 has 2 different So deck A has 2 different packs and 5 different has 2 different wheels and 5 different packs to choose from. It's just repeated addition. The 3 times 2 is going to get you the 6 that we saw before, the 6 outcomes, and then multiply that by the 5 packs. Because each deck can be matched up with 2 wheels for a total of 6 outcomes here, and each of those 6 outcomes can be matched up with any of the 5 packs. So you have 6 different wheel deck combinations that can each be matched up with pack 1, pack 2, pack 3, pack 4, and pack 5. And so that, again, will get you the 30 outcomes. So just to explain it one more time with a little visual aid, the 3 times 2 represents the decks and wheels. You multiply that together, you get the 6 total outcomes, because each deck can be matched with each wheel. So A can be matched with D and E, B can be matched with D and E, C can be matched with D and E. So there's a total of 6 outcomes there. So you have like outcome 1, 2, 3, 4, 5, and 6. And then each of these outcomes, 1 can be matched up with any of the 5 packs. So there's 5 outcomes here with wheel deck combination 1. Wheel deck combination 2 can be matched up with any of the 5. So it's 5 plus 5 plus 5 plus 5 plus 5 plus 5, or 5 times 6, which again is 30. And once again, if you don't understand this, please pause the video. Let me know. I can sit down with you, go through it a little bit slower, and maybe explain it a little bit differently. Maybe using a smaller example. So that is kind of the gist of the fundamental counting principle. It boils down to a really simple process, which is just multiply your choices together. If option 1 has 3 choices, and option 2 has 2 choices, and option 3 has 5 choices, you're just doing the 3 times 2 times 5. However, it does get changed up a little bit occasionally, and I'm going to go through a problem like that right now. Sometimes you may see a problem where as you choose, options become limited, and that'll make more sense as I explain this next problem. So in this next problem, we're using the numbers 1 through 5, and they're in a bag. Okay, so we've got some pieces of paper. They're labeled 1 through 5, and they're in a bag. And I want to know what are all the possible. And you're gonna pull out 3 numbers. You're gonna pull out 3 numbers one at a time. So I'm gonna pull a number, look at it, write it down. Pull a number, look at it, write it down. Pull a number, look at it, write it down. Now, the way this is going to work is you're going to pull a number out, but you're not going to put it back in the bag. So the first pull out of that bag, there are 5 numbers. So there are 5 choices or 5 options or 5 possibilities for pull 1. However, since you're not putting that number in the bag, pull 2 changes. Yes, there were 5 numbers in the bag, but now there are only 4. Pull 3 changes. Because now we've removed 2 numbers from the bag and pulled 3, so there's only 3 numbers left in the bag. So our first pull there were 5 numbers, the second pull there were 4, and the third pull there were 3. So there's a total of 60 combinations of 60 combinations that I could get, or 60 outcomes that I could get, pulling 3 numbers out of the bag and removing the number permanently from the bag after each pull. So I could get the numbers 1 through 5 for digit 1. Basically what's happening is I'm getting a 3-digit number in the end. And the first digit has 5 options. Okay, so this has 5 options. The second digit only has 4 options. And the third digit only has 3 options. Okay, so that's essentially what's going on there. And so you multiply those together and you find out there's a total of 60 different outcomes that you could get. Now, that could change. It all depends on how the problem is worded. This occurs if you are not putting the numbers back in the bag. So every time you pull, there's a different there's a different number of options for you to obtain. So the first pull, there were 5 options, then 4, and then 3. However, if you are putting the number back in the bag, okay, so we're putting the number back in the bag. At that point, the number of options for each pull is the same. I'm going to have 5 numbers times 5 numbers times 5 numbers. Each pull has 5 potential numbers in it, so there's a total of 125 combinations. Okay, so this is up here. This is when we take the number out of the bag. And we don't put it back in, and this is when we put it back in the bag. This is how it changes the number of outcomes. Okay, this is also how it changes what you do with the fundamental counting principle. You have to pay attention to the number of possible outcomes for each pull. So pull 1, I have the numbers 1 through 5. I could get the numbers 1 through 5 here, and I could get the numbers 1 through 5 here. So there's a total of 5 numbers, 5 numbers, and 5 numbers. So a total of 125 combinations. And that's probably the most complicated problem you'll see is these problems where you're like pulling things out of bags and you may or may not have the same number of outcomes each time depending on how the problem's worded. But this is why you need to take your time and read the problems carefully. Don't zip through them thinking, oh, I know what I'm doing. I don't need to read the directions. I don't need to read the rest of the problem. I only need to read the first sentence and I'll know what I'm supposed to do. Sometimes that may be true and sometimes that may not, and it could cost you. So please, please, please take your time to read these problems and pay attention, please. That's really all I got for you on counting outcomes with the fundamental counting principle in this video. In the next video, we'll be talking about probability and how you can use tree diagrams and the fundamental counting principle to help find the probability of an event.